Am I on? Usually I hear a beep. So I'm just staring at you guys, wondering if I'm on yet. Hey, we are in Unit 2, Lesson 4. We're still learning about linear equations. We haven't gotten into inequalities or systems yet, but now we're talking about equations and their solutions and what that means. So in pre-algebra, you would have learned that a solution to an equation is a value or values that make the equation true. So you always get down to the bottom of an equation and you see like x equals 4. Well, that means you can take that 4, plug it back into the equation, and it works out to be a true statement. So that's what we're going to do. So today we're going to verify, find solutions, checking if values work, etc. So let's recall what we know about solutions to equations. Really quick, an equation is anything that has an equal sign, all right? We have an expression equal to an expression, and it's called an equation, all right? It could be 3x minus 2 equals 4. Okay, what does x equal? So this is an expression equal to an expression. And to find the solution, we're going to figure out what x equals to make that equation true, okay? Okay, so let's jump on in with a warm-up. A granola bite contains 27 calories. Most of the calories come from C grams of carbohydrates. The rest come from other ingredients. 1 gram of carbohydrates contains 4 calories. Okay, so 4 times C plus 5 equals 27 represents the relationship between these quantities. Okay, let's see. What could 5 represent in this situation? Right? We know that C is calories from carbohydrates. My head is in the way. It's just, it's just not a good place to put my head because I tend to look at myself when I'm talking and my camera's up there. So it's quite confusing. So I apologize. Let's try right up here. There's just no good place. Okay, so what does that, C is the calories from carbohydrates. The rest come from other ingredients. So we know 27 is the amount of calories in the granola bite. 5 would be the rest come from other ingredients, okay? The rest come from other ingredients. So I'm just going to say rest of the calories. So Priya said that neither 8 nor 3 could be the solution to the equation. Explain why she's correct. Well, let's plug in 8 to the equation and see what happens. So I'm going to replace C with 8. And at this point, I usually put a question mark over the equal sign because I'm not sure. So 4 times 8 is 32, plus 5 is 37. So 8 is not a solution. Let's try 3. 4 times 3, just replace, substitute, equals 27. Again, I'm going to put a question mark there. 4 times 3 is 12, plus 5 is 17. So 3 is not a solution, okay? Now it says find the solution to the equation. Well, in awesome fashion, I'm already out of room, so I'm going to do number 3 up here. If I want to find the solution, I want to find what value for C makes the equation true. And I know you went through this in pre-algebra, but we will review. I'm going to subtract 5 from both sides. Okay? In algebra, I can do that. What I do to one side an equal sign, I have to do to the other. So then I get 4C equals 22. Now I'm going to move this up here. Now I'm trying to figure out what C stands for. So now I'll divide both sides by 4. and I get C equals 5 point something. 5.5, that was easier than I thought. Sometimes. 5.5, that would be calories from carbohydrates. So most of the calories come from C grams of carbohydrates. Sorry, this would be the grams of carbohydrates. How did you know that 8 and 3 are not solutions to the equation? How did you find the solution? Well, I tested it. Substituted. Okay, how did I find it? I used my algebra skills, which we learned in pre-algebra. And I would say that I isolated C. Okay, I solved for C. Those are all words that we're using. In general, what does a solution to an equation mean? Okay, it's the value for the variable that makes the equation true. Cool? See, I'm looking at myself, not the camera. I'll try to look at the camera. Maybe it's something I need to practice. All right, Jada. Jada has time on weekends to earn some money. A local bookstore is looking for someone to help sort books and will pay $12.20 an hour. To get to and from the bookstore on a work day, sorry, I just realized I can put this over here and it's not in the way of anything. And I can still try to look at the camera. To get to and from the bookstore on a workday, however, Jada would have to spend $7.15 on bus fare. All right. I found in my teaching career that coming up with the equation to represent situations is the hard part, and it gets easier with practice, I promise you. Because the first question is write an equation that represents Jada's take-home earnings in dollars, E, if she works at a bookstore for 8 hours in one day. So I know that I want E equal to, okay? Now she's looking for someone to help sort books, pay $12.20 an hour. That's a good paying job. $12.20 an hour. To get to and from the bookstore on a work day, she would have to spend $7.15 on bus fare. So she's getting $12.20 for every hour she works, and to take away her take-home earnings, she's going to take away $7.15 on bus fare. But that would be each day. Okay, it doesn't say this is just one day. Weekends to earn some money. I think I need to put in a variable to represent each day. Yep, let me think about that. I don't want to get that wrong. Nope, we're good. I checked. So our earnings, $12.20 an hour minus $7.15 for bus fare. So that would be per day. Oh, right there it says it, in one day. Silly me. It always pays to read the question again. All right, one day Jada takes home $90.45 after working 8 hours and after paying the bus fare. Write an equation to represent this situation. So she took home, so we're going to substitute $9.45 equals $12.20 times H after paying bus fare. Yeah. So $12.20 an hour and paying bus fare. She made $90.45. That's good money. That's a lot of sorting of books. right? I know I split up the slide into two, so I want to keep that there. But you guys have all of this in front of you. It's okay if I move my slide away. Now, number 3 says, is 4 a solution to the last question you wrote? I'm doubtful that 4 hours is going to make that much money, but let's check. So is 4 a solution? So I'm going to substitute 4 for H. So 1220 times 4 is $48.80. So no, 4 is not a solution. Take away $7.15, and I get $41.65. So $90.45 does not equal $41.65. So 4 is not a solution. All right, how about 7? Let's change colors. $90.45 equals 1220 times 7 minus $7.15. So 1220 times 7 minus 715 is $78. Oh, I forgot my question mark. $90.45 does not equal $78.25. So 7 is not a solution either. Okay, 4 or 7. Okay, explain because 4 and 7 did not make the solution true, make the equation. Okay, did not make the equation a true statement. If not, be prepared to explain why there are not solutions, why they are not solutions. Then find the solution. I apologize. I believe I put that in the wrong box. So if so, be prepared to explain. Well, they weren't. So if not, explain why not. Right? Okay. Then find the solution. So let's find the solution. $90.45 equals 1220 times H minus $7.15. So we're trying to solve for H. I need to isolate H. So let's move everything else away. So first I'm going to add $7.15 because it gets rid of it on that side. I get $97. That's how much she takes home before she pays for her bus fare. Okay, now I want to divide both sides by $12.20 because then I've isolated H. I've got H all by itself. So divide by 1220, 8. So H equals 8 hours. So she worked 8 hours and made a pretty decent amount of money. In this situation, what does the solution to the equation tell us? That, what's her name? Priya? Jada. Jada worked 8 hours and took home $90.45. And you could say after paying bus fare. If you wanted to. That last part's not necessary. Okay, cool. What equation did you write to represent Jada earning $90.45? We did earnings equals hourly wage times the amount of hours worked minus bus fare. How did you know 4 and 7 are not solutions? I substituted 4 and 7 to see if they made a true statement. If they made the equation true. and they did not. All right. Next activity. I think this is our last activity. So 1 gram of protein contains 4 calories. 1 gram of fat contains 9 calories. A snack has 60 calories from P grams of protein and F grams of fat. This equation represents the relationship between these quantities. So protein contains 4 calories, which is why we have P times 4. Fat contains 9 calories, which is why we have 9 times F. And a certain snack has 60 calories from protein and fat. Determine if each pair of values can be the number of grams of protein and fat in the snack. Be prepared to explain your reasoning. So we're going to substitute. Instead of P, I'm going to write 5 because it's 5 grams of protein and 2 grams of fat. So instead of 9, I'm going to write 2, and I'm going to see if that equals 60. So 4 times 5 is 20. 9 times 2 is 18, and that does not equal 60. Okay? And my reasoning is because it's not a true statement. Okay, how about 10.5 grams of protein and 2 grams of fat? So I'm going to substitute 10.5 in for P and 2 in for F and see if that equals 60. 10.5 would be 40, I think 60, plus 18 is not equal to 60. It's 42. My math was wrong. I tried to work it out in my head and it didn't work. 42. 42, 50, 60. That is equal to 60. Doing fantastic. Okay, so yes. True equation. All right, how about 8 grams of protein? Um, 4 times 8 plus 2 times, nope, 9 times 4. Does that equal 60? 9 times 8 is 32 plus 36. 6, 7, that does not equal 60. Oops, 8, 68. Get my eraser out. Not a true equation. Cool. All right, let's talk about this. If there are 6 grams of fat in the snack, how many grams of protein are there? Show your reasoning. Ooh. Now we get to work through some variables. So we have, 6 grams of protein. Nope. 6 grams of fat. So I want to keep this equation balanced. So how many grams of protein are going to keep it equal to 60? So 9 times 6 is 54. Nope, sorry. Here we go. See, I'm keeping everything lined up. Now I want to subtract 54 from both sides to isolate the P. There's still a 4 in front of the P. So I have 4P equals 6. Divide both sides by 4. I have P equals 1.5. So that would be the grams of protein. 1.5 grams of protein. Okay, my reasoning is my balanced equation, and I solved for P. Okay, so showing my reasoning and labeling my answer is important. In this situation, what does a solution to the equation 4P plus 9F tell us? Give an example of a solution. In this situation, a solution tells us how many grams of protein and fat are in a 60-calorie snack. And an example of a solution would be what we did right up here. 10.5 grams of protein and 2 grams of fat would be a snack. I'm not sure what that word is. 10.5 grams of protein and I think it was 2 grams of fat. 60 calories. Okay, make sure I got everything there. Pair of grams of protein and fat in the snack adds up to 60. Cool, we got it. Okay, let's just summarize. We always do a little summary at the end. In this situation, what does it mean when we say that x equals 12 and y equals 15 are not solutions to the equation? I would say P and F. I think that's a typo. What does it mean when we say that they are not solutions? It means that when we substitute them, they are not, they don't make the equation true. So after substituting, the equation is not true. How did you find out the grams of protein in the snack given there are 6 grams of fat? I isolated P. I got it all by itself. And it's important to say I did this by reversing PEMDAS. Okay, PEMDAS is the order of operations. Can you find another combination that's a solution? Yes, we can. I don't know if we have one. Nope. It was 4P plus 9F equals 60. I can pick any P, almost any P. Substitute and solve for F, isolate F. I can plug in values and solve for the other. Since it's just a linear equation, there's a lot of different values that will work for it. And we're going to get into that in another lesson where we're going to talk about lines and many values of X and Y that work for a line, okay? So we're going to hold on that one right now. How many possible combinations of grams of protein and fat would add up to 60 calories? The answer to this is almost infinite. Infinitely many, I hope I spelled that right, combinations. Because we're not looking for whole numbers here, we can have decimals. So almost infinitely many combinations of protein and fat, which in this case is going to be P and F, would add up to 60. What does the equation for x plus 9y, and again, we're going to go P and F, tell us about the calories in a snack? Well, this would be the same 4 calories for a gram of protein and 9 calories for a gram of fat. But here we have a snack that has 110 calories in it. Right? The fat and the protein aren't changing, but you just have more calories in the snack. And in this situation, it means the same thing. How many grams of protein and fat make up the 110 calorie snack? Is the combination of 11 grams of protein and 5 grams of fat a solution to the 110 calorie? So I just substituted as I was talking. 4 times 11 plus 9 times 5 is 89. 89 does not equal 110. So no, because it's not a solution to the equation. Consider this equation. What does it tell us about the snack? Well, and this is, again, fat. Let's see. 4 times 5 is 20. 9 fat equals 110. Subtract 20 from both sides. And I have 9F equals 90. Divide both sides by 9, not F. And the amount of fat in there is 10 grams. That particular snack has 10 grams of fat and 5 grams of protein. 5 grams of protein and 10 grams of fat in that snack. Lots of things that linear equations can tell us. All right, so what we did today, I can explain what it means for a value or a pair of values to be a solution to an equation. And I can find solutions to equations by reasoning about a situation or by using algebra. And these are our vocabulary words. I don't think we have any new ones yet. Nope. Good job today.